Right, so it's 7 o'clock now. Just like to welcome everyone that's joined to tonight's British Astronomical Association webinar. Very pleased tonight to have the pleasure to welcome Tim Hames from the Asteroids and Remote Planets section of the BAA. Tim specialises in observing occultations. And tonight he's going to talk a bit about how you actually go about doing that. So without any further ado, I'll pass over to Tim and he'll take it from there. Okay, Tim.
Thank you very much. I need to share my screen. I've still got a view of you, Callum. Right, can you see that?
Oh, you can see you.
Okay then. Well, first of all, this is the instrumentation I'm currently using for...
Hi Tim, I think you've not got your screen sharing going quite right.
Right.
We just see a picture of you at the moment.
Does that look better?
Yep, that's the PowerPoint in its...
Can you see the screen behind it?
I don't think so. I think that's just the PowerPoint.
Right. I need to go through this process of finding the screen again. Okay, well, I'll dispense with the actual videos themselves and go straight to the PowerPoint.
Yep, that's looking fine now, Tim.
So sorry, I won't be able to show you the videos. Maybe there'll be time later once I've.
Yeah, when we get to the end, I might get a chance to look at the videos as well.
Right. So this is the equipment I'm currently using for lunar and asteroidal occultations. It's a C11 on an EQ6 Pro mount, and I'm using a digital camera with a reasonably good field of view. Obviously, with lunar occultations, it's not too difficult to find the stars. They're obviously near the lunar limb. But in the case of asteroidal work, it's more difficult to find these fainter objects, and a good go-to instrument is absolutely necessary. Otherwise, you can spend an hour trying to find the field of view, which is about a third of a degree across, which is ideal for finding field stars, as we really want to monitor field stars as well for asteroidal work. When it comes to differentiating small fluctuations in light, we need to be able to cancel out this seeing, for instance. So on the next slide screen here, we're displaying a lunar occultation from the point of view of 3 different observers, and each observer sees a different event, a different part of the lunar surface, a different contact angle, and each observation is unique. And below it, we've got a similar situation with an asteroid. We have the same 3 observers. Each observer is observing a different chord from behind the asteroid, and they combine to form a 3-dimensional shape eventually, with enough observations and with observations of light curves of the asteroids themselves, the fluctuations in light, we can possible to construct 3-dimensional shapes for the bodies, which is a very upcoming project for professional astronomers. And as an amateur astronomer, we just contribute the timings. But it's very interesting to see what can be obtained from our results. So just going through the lunar occultation aspect, I observed a double star here, which gave a step event, and that in itself was quite interesting because the lunar limb can actually resolve quite fine double stars by virtue of the fact that there's a slight step in the light curve. And although many people used to, and continue to do so, observe visually, a visual timing doesn't really give us any means of making measurements of light curves. So over a period of time, and roughly from about the year 2000, a lot of observers have converted to video, because that has a very fine resolution in time, 25th of a second. And for the more advanced USB 3 cameras, planetary cameras, you can monitor these occultations at 100 frames per second if you wanted to. And that's what I currently do. This is a setup showing my video equipment. This is the Watek 910HX video camera, which is probably the most sensitive camera in the Watek range. Is actually about twice as sensitive as any of the current CCD cameras that you can buy. We don't know exactly why, but it certainly gives results which are superior, perhaps by as much as half or one magnitude. This is the video time inserter which we use with video cameras. It gets its time from GPS and it's inserted into the video signal through this box, and then we can record it onto a computer via an analog to digital converter. So what sort of cameras can we consider for this sort of work? You might already have them. So any monochrome USB 3 camera used for imaging planets would be absolutely fine. They can record at 30, between 30 or more, or down to 3 frames per second, for instance. More advanced USB cameras, fits formats, 1/2 to 2 seconds, that's absolutely fine for longer duration events. Obviously, I've just recommended the video side of things. Any video camera that is characterized by dangle on this website, I'll put the link there. I can activate the link, but I won't do that for the time being. But he investigates all the common cameras and it characterizes them very, very carefully. One of the more recent additions to the camera market is a camera which was designed by IOTA, the International Occultation Timing Association, using a camera here, which is normally used for mobile flying equipment, but it can be used for astronomy as well. And it was converted to do a frame integration, so you can buy those from IOTA at a reasonable price. It's almost as sensitive as the Watek. Then also on the market now, there is this QHY174 camera here, which you can buy as an imager, but you can buy a GPS module that screws into the back. And then there's also a new development by some amateurs to develop their own cameras. There's lots of free software around for recording your data, assuming you're not using a stopwatch. Virtual Dub is a very old and current program. IOTA video capture, very easy to use, to set up, install it and run it for 8-bit AVI. Then there is a more advanced bit of software called OcuRec by Hristo Pavlov. It takes a little time to get used to using it, but the results are absolutely first class. And most of the USB cameras of occultation interest can be run with SharpCap. This is the prediction arrangement for lunar occultations. In fact, when they were first predicted for the BAA handbook, they were using an analog machine called the occultation machine, and there's a beautiful paper written by Alex Pratt on the subject of its development. And predictions were available to an accuracy of 0.1 of a minute. And Gordon Taylor used this equipment for his predictions at the Nautical Almanac office, and subsequently appeared in the BAA handbook. Currently, I get predictions from the Occult4 software, and I put these in the lunar section circular. And these go down to magnitude 9. So if you log on to the BAA website and go through the lunar section facilities and archives, you will find the current circulars and more predictions for lunar occultations. Only for Manchester, I might add. I can't put in predictions for all locations, but if you become interested in this, I can produce occultation predictions for your particular latitude and longitude, and down to whatever magnitude you want. So this is the screen, front screen of Occult4 software by Dave Herald, and you can press that button there and you'll get your predictions for your location. To summarize it briefly, there's a lot of facilities within this software, so it's well worth investing in some time and understanding its intricacies over a period of time. What about observing visual occultation as well? This is a facility, an image which shows Aldebaran disappearing behind the dark limb of the moon, imaged by Alex in 2015. And the bottom 3 images show the reappearance of the bright limb. The interesting thing is that he's also managed to video it. And Aldebaran is a very large star, and it is expected to fade. And at 50 frames per second, I noticed that there's only one time point where it indicates there is a fade, which is unusual. And yet the reappearance does show a gradual reappearance. That's entirely down to the contact angle of the moon. So things are always sort of changing in respect to what you actually detect. This is the double star, which I was intending to show earlier on, but it was recorded with my QHY camera. So it shows the double star expanded there, and it's just disappearing into the lunar limb at this point here. And whilst recording it by video, you can see the step in the light curve very easily with iMovie software, which is a free application. And if you fancy using it, you can contact me and I can give you a copy. But it's not very easy to use, and but it is extremely detailed in terms of actually analyzing light steps and durations, and it tries to match a theoretical light curve to your observations. And in this case, it's revealed a duration of 11.03 milliseconds. And from the step, it can calculate the magnitude difference of the stars. And if that was repeated at another observing site with a different step duration, it's then possible to work out this separation of the 2 components. And there's a small section within the BAA lunar section which is doing this. So yes, double star observations and their discovery. Well, many years ago, when the occultation work was commenced within the lunar section, a lot of people were observing step and fade events by visual means, and that has left us a legacy now of suspect double stars. And if you look in the predictions by Occult, it'll identify all those suspects and ask for light curves of the stars involved, so that we can deduce whether they really are doubles or not. In fact, when it comes to observing double stars, you don't have to have the absolute universal time for the event, just the difference in time of the 2 components is sufficient. So you don't need to have elaborate absolute timing equipment. You can count the number of frames and deduce the time from that. So this was a discovery made by Alex quite relatively recently. It's 2020, April 12th. He was observing an occultation of a star, not a particularly significant star. It's a relatively faint star in the extended ZC catalogue. it just came up in his predictions. He measured it, recorded it, and noticed there was a step in the light curve, and it wasn't a known double star. So he was able to deduce the magnitude difference and the separation at that point. And I think time will tell when we eventually get some more observations, we can determine the position angle. It's not necessary to get two observers observing it at the same time. You can compare your observations now with those which were done a year or so ago or a year in advance for another part of the world, since double stars don't change that much in that much time. So we await more observations on that. So this is something I've been looking at recently for lunar work. It's a very fast frame rate light curve of an occultation with 20 centimeter Newtonian. This was expected to be a double star of two components, 7.5 and 8.4. I don't know where this information comes from, but at the position angle of the moon I was looking at, there was no indication of a double, unless it's actually hidden underneath here. But it does show a sort of gradual disappearance at the edge of the moon. This, incidentally, is a light curve which I took of Epsilon Capricorni, which was highlighted in one of the BAA, on the BAA website, encouraging people to have a look at it. I was absolutely appalled by the quality of the seeing at the time, and this is done at the same frame rate. And the scintillation has actually completely destroyed the light curve, and any information that may be hidden in this region of the disappearance. So that wasn't terribly successful. That's just something else to bear in mind. You can't do excellent work in bad seeing conditions. So I'd like to move on now to grazing occultations. This is a great interest of mine. I've been quite fortunate that over the last few years of being able to observe one every year so far by video for the last 5 years. And these involve quite a bit of planning, finding a location to set up your telescope at the right time. So what I'm going to do is go into a little bit of detail on how I do that. And of course, grazes are quite often reported by local astronomical societies who get involved in sort of teamwork or observing from their back gardens. But it's more likely to observe something if you actually travel to the shadow itself, and that's what I tend to do. Incidentally, this is a link here to all the Grays occultation data that's given in the BAA handbook, the data for this year. So if you click on that, I've gone forward one. I won't bother to go back again. So this is the limb profile for a lunar occultation, which I observed on that particular date. And you get one of these limb profiles with every prediction. And it includes a KMZ file, which you can display in Google Earth, and it gives you a green line. And that is the mean, the occultation of the star along the mean limb, which is the dotted line. And clearly the actual limb exists either above or below the mean limb. So you need to position yourself where the star will be disappearing behind these limb features. And in this particular event, the best events were about 0.8 kilometers, judging from this histogram here, which is a sort of prediction of the number of contacts. So I wanted to be able to be in a position about 800 meters south of the mean line. And this is the position I found near South Lee, which is just to the west of Oxfordshire. And I located myself in the corner of a field out of the way of lights and passing traffic. It's always quite difficult to find a position which sort of conforms to dark skies and lack of disturbance. So places like campsites are good places to set up with permissions. Public car parks, yes, I've used those. Corners of fields, private locations with permission, which have all been very successful. So here's what sort of events do we see at Grazes? Well, I've seen some really unusual spikes and double stars. There was a double star, which one component was occulted first and then reappeared, and they both reocculted at the same time. This one shows reappearances in fades over several frames. These incidentally are the Graze predictions in November, 3 of them taken from the BAA handbook, and I've plotted the KMZ limb lines across the UK. So I'm hoping to observe one of these, perhaps the November 16th event, which is near where I am. And the Graze data is at the link at the bottom, if you fancy having a go and planning it yourself. Now I'd like to pass on to asteroid occultations, which is of great interest to a scientific community, and they are more difficult to observe, but the rewards are greater. So this is my own personal tally of events since 1980s. I've been observing them on and off for quite a while. None were particularly successful, apart from the Sigma Sagittarii occultation by Titan, which is that little yellow bar there. That was extremely well observed over the UK, and I was just one contributor. Then in about 2010, I managed to get my first video occultation, and since then I've only had 1 year when there was no positives observed, and all the others have been increasing in numbers. That's because of the number of predictions and the improvements in the predictions, and in particular the improvements in the asteroid orbits over time. And now I read that there are over 1 million asteroids and comets now known, and comets are also of interest from the Occultation Observer. Not me personally, but there is a small group in Europe which are predicting their own, making personal predictions of comets occulting stars in order to try and deduce whether the size of the nucleus. I don't believe any positive observations have been observed yet, but there are people attempting this. This is the Thompson photographic refractor at Hurstmansoe, and it was used for updating cometary orbits in the 1970s and 80s, and Gordon Taylor used it to improve his predictions of asteroidal occultations, and he was the first person to really make some headway in predicting these events at a time when orbits were very, very well unknown. And so also with the star positions, there was also obviously a bit of an unknown quantity as well then, compared to the great accuracy we obtain now from the Gaia catalogue. Timing occultations leads to the best available data, providing positions with possibly up to 10 millisecond accuracy with the most recent star positions from Gaia. And professional observatories are engaged in all sky. Camera surveys are obviously computing the movements of asteroids as well, and they can lead to improved orbits. So if you go to the Steve Preston's IOTA website, this is actually for 2014, but the format is the same. You'll be given a list of brighter, more favorable events. So all these stars in this particular list are quite bright, usually brighter than magnitude 12, which are easier to observe. And they tend also to be of fairly long duration, these particular events which are chosen, which makes them easier to monitor. There's one here on the 3rd of April 2014 for Pallas, which incidentally, an event of Pallas is occurring this evening. But I understand looking out of the window, and I'm not going to be seeing it. The star in this case was 11.3, and one of the difficulties in observing relatively large asteroids is their brightness, because the stars in relation to them tend to be quite small and less bright. So the contribution of the star to the total light is quite small. So during an occultation, there isn't much of a magnitude difference. And this one here is 0.04 of a magnitude, which in this case, I think is almost beyond detection for asteroidal occultation work. But 0.1 of a magnitude is a possibility. We can do that. These sorts of asteroids, but typically the difference in drop in brightness is quite large, and usually the star disappears, which is the ideal situation for an asteroidal occultation of a star. This is an example of 5 Astrea occulting Hipparchus star on August 26 of 2014. But the features of this prediction are similar to many others. It gives you this asteroid name, star number, date, the time which the event will be visible from the point it intersects the Earth and when it leaves the Earth. And you really need to deduce the time at your location within a minute, which is absolutely fine. And to make sure you observe for a couple of minutes on either side of the mid time of the occultation. And here it gives you the magnitude of the star, the duration, magnitude drop, which is different in red. If you've got a red sensitive camera, use the red magnitude drop. And then in this area here, it gives you the magnitude of the asteroid and a star map of sorts. I'll come on to star charts in a moment. This is Occult Watcher, a very valuable tool. I would recommend anybody who's interested in asteroidal work to download and install it, but it can be configured to select particular events suitable for your instrumentation, time of night, magnitude drop. So if you don't want to observe stars fainter than 13, you can configure it to remove those fainter events, or events which are too low in altitude or too far away from you. So this will then select those events which are available to you through various feeds of data. And those feeds, which you can select on a list, either come from IOTA or in some cases now the UK list. There's someone at Reading, John Talbot, who's generating a list of occultations for just the UK, but there are other lists as well which intersect with them, lists from Spain and Italy, which, although they're predicted specifically for those areas, the tracks do cross over other parts of the world as well. And indeed, also the professionals produce their own list, and you can select those lists as well if you wish. So you can minimize or maximize the number of opportunities through this tool. Indeed, when you find an event of interest and you say you're going to observe it, you can enter it in your list, my events list, and it'll come up and tell people that you're actually observing it, and you can see who else is observing it. So, what do we get with asteroid occultation events? Well, we've seen some very unusual results over a period of time. These are a few examples from this year. A gentleman, Pierre Lecam in France, one of his first events, I might add, he was a new observer. He was observing this asteroid 885 Ulrich, and he observed 2 occultations, one after the other. One was a duration of 4.8 seconds and the other 0.9. and he was using an exposure of 0.15 of a second with the QHY 174 GPS camera. And this in itself tells us a great deal about what might be going on here. The theory is that it's not a double star that's causing this, but the shape of the asteroid. And it could be two asteroids or bilobate in nature. And that is a very interesting asteroid to follow in future. And it's only occulted a star the first time. Well, it's observed for the first time to occult a star. So hopefully there'll be other occasions to see it. So this was his data. This line here, line 3 and 4. It's effectively 2 events. And these were the other observers. And as you can see, you can start to draw an outline of this profile. So these are the, we're not using a great deal of high accuracy work here. These are observations to within a 1/10 or possibly a 1/5 of a second, provided we add in an uncertainty, which is extremely important, really, to assess how good our observations are. And when we report them with this uncertainty, depending on the light curve. And I won't be going into any analysis at this stage because that's a bit involved, but I can do that another time perhaps. But it's not difficult to analyze these things. There's some software called Tango, which is a very useful bit of software to analyze these light curves. This is another event which I was involved in. In fact, myself and another colleague of mine, Simon Kidd, who's over in a bit further east of me, but we observed these 2 chords here of roughly equal duration. And there are 5 other observations, all of roughly the same duration, which was rather unusual. So the only outcome for that, to explain that, is the fact that it's an elongated object. And this has actually been observed before, and a 3D shape has been built up. And on other occasions, it's obviously shown a much smaller profile. So we were fortunate in this case to actually be able to get a lot of chords over its longer dimension. So this is a very nice observation done by a German astronomer, Oliver Kloss, with a 25 centimeter LX200. It was a measurement of the atmosphere of Pluto, and he observed it with a WATEC 910 video camera under very good conditions, and he got a very, very nice light curve, which was passed on to the professional astronomers. We were looking at the size of the expansion or contraction of the atmosphere of Mars. I did an observation of Triton's atmosphere in 2017 when it occulted a star. There's the star and the moon is sort of coincident there, but I was able to, with a bit of planning, a lot of planning. In fact, I tried lots of different techniques to try and optimize the observational results over a period of weeks by imaging Neptune. And on the night I decided to use, I was going to use a red filter because it was at twilight. I wanted to improve the contrast with 30 centimeter Ford telescope. Triton was 13.6, the star was 12.7, the drop was 1.4. And I settled on an exposure of 0.64 of a second. And but you can actually see the disappearance, gradual reappearance through the atmosphere of Triton, which was very rewarding. And I sent those observations off as well to the Lucky Star observers at Paris. I haven't seen the results yet. It takes a long while for these for this data to be published. An observation of Pallas this year, not by me, but by 44 observers in Europe. A very nice outline. And this was intended to be the observation I would make this evening. This is a prediction of where all the observers would be for this evening's event, which incidentally was over Europe and the North Sea, and in the UK was just sort of on the edge of it. And this is my position here, just outside the edge of the shadow, but I won't be observing it because of the weather conditions. So where do our results go in asteroidal work? Well, it goes on to the urasta.net website, where all the observations are compiled in a summary format. So I recommend anybody to go in there and see what the UK and other European countries are up to. One of the great results of recent occultation work is the discovery of rings around at least 2 objects, Chiriclo. That was, I think those rings were discovered several years ago, and also rings around Hume, which is a TNO. And these are sort of exciting results that really get my mouth watering. I love to be in a position to be able to measure these rings myself, but we haven't really had any opportunities where these objects have been occulting objects in the Northern Hemisphere in the right conditions. So we just wait for the right opportunity. Although I do know of some people who go abroad and observe these things very successfully. From the Lucky Star website, this is the Pro-Am website. This is an example of the occultation by a TNO, which is going to come up in later in a few weeks' time. But unfortunately, I'm just showing it as an example, but it's going to be in twilight and it's not going to be observable. But some of the features of the prediction are shown here. They tell you the RA and deck of the star, magnitudes which you can ignore, because further down it gives you another G magnitude here, which is one which we're really interested in, which is the equivalent. It's a Gaia magnitude, but it's sort of converted to something we understand in terms of star brightness. So it is quite a faint star, but it is possible to observe these things with longer exposures. And if it were visible, if it had occurred 3 hours earlier in the night, I could have used my C11 with perhaps a 2-second exposure, maybe 1 or 2 seconds to record this. At least I would have had a go anyway. Lastly, there are some occultations that are observable, hopefully. I've picked them out, which are of long duration and large shadows. This one here, October the 19th, is 762 Pulkova. It's at late evening. Hopefully, if I didn't destroy this slide, I could actually show this up, but hopefully it comes up. Yeah, this is the actual observation prediction on the IOTA website.
Tim, you would need to share your browser on the.
Sorry, you can't see it?
No.
Oh, good.
On your share screen, you should get an option to share your browser.
Okay, I'm not going to try and do that.
Or try it afterwards, maybe.
Maybe, yes. Okay, maybe I will do that, yeah. Okay, I'll continue on without further ado. So here we have the path that sort of cuts across London, Southampton, parts of Eastern England. And then there's also this asteroid here, 313 Chaldea, October 29th, nice wide track again. Here the duration is 10.3, magnitude 11.5, duration 9, magnitude 11.3. So these are events which could be observed. I dare say they could be observed possibly visually, but definitely by some sort of planetary webcam type arrangement, and also video. So this one here cuts across Ireland, Northern Wales, Central England, and down across Kent. Well, there we are. That's that's the end of my presentation, and thank you very much for your attention. It's rather unusual to not be able to talk to an audience and hear their reactions, but I hope there'll be a few questions I can answer now if time permits. Thank you very much.
Yeah, thank you very much, Tim.
I'll stop the share.
Okay, yeah.
Okay.
Oh, I'll put my video on as well. So if anyone's got any questions, if you want to enter them into the chat, either on Zoom or on YouTube. We had just a comment on YouTube from Eric Walker, who's in Conan Bridge in Scotland. And he just commented that he has his ZWO ASI 071 mono camera, which he uses with SharpCap for astrophotography and webcasting, and that he thinks that would be okay for using with doing occultation work. Tim,
you said the WATAC 901H?
No, he said it's an ASI 071.
Oh, right. Yeah.
One of the ZWO range, I think.
Okay, yeah. Yeah, with SharpCap, yes. Well, obviously, it would work, and it's a USB camera, I presume. So
yeah, I would think so. Yeah.
Okay, so if you're going to do any timing, you need to get your computer clock synchronized to UT as well as you can. And if you're using SharpCap, I think you can put the timestamps on the frames, I believe. So that is the way to go forwards, and then record it at whatever event you're going to observe at a reasonable frame rate. So yes, you can do it.
So how accurate are the frame rates, Tim? If it's like 30 frames per second, is that really 30 frames per second, or does it vary depending on how the computer performance?
No, the frame rate should be pretty good. It's controlled by the camera, so I haven't found any instances where the frame rate has been variable. There are occasions if your computer is not up to it, you may drop frames. But as long as the time is actually on the frame, it doesn't really matter. Because when you come to analyze it, you're looking at the individual frames, and if they're timestamped, then it doesn't matter if you lose frames, or if they're not exactly at the right rate. It's not important, as long as there's a timestamp on the frame.
So, yeah, so you can always reconstruct the light curve from the timestamps. Yeah,
that's what the light curve will do. It'll take each frame and present it as a spot on a graph.
Mm.
Yeah. So yeah, I use Tangra to do that. It just reads an AVI file, and you put your cursor on the star, and as a little aperture, and then you can put it on another star as a reference, and then you start go, and it'll measure the stars over the period of your observation of your AVI. Or it could be an SER file, of course. They're just as good.
Would you be able to post some of these web links on the BA forum, Tim, afterwards or tomorrow?
Yeah, the links at the bottom of the on the last slide I can put up on in wherever you want me to put them.
Well, yeah, either send them to me, and I'll post them on the forum probably.
Okay.
Or if you want to post them on the forum yourself, then that would be fine, whichever you prefer.
Yeah, sure thing. We can talk about that in a minute. Yes. Hi, Tim. Showed a spike.
Question from Roger Divick. One of your lunar occultation slides of a double star showed a spike. Any thoughts?
Where was the spike? I'd have to replay the I'd have to share the screen again. Okay. Well, I'm not quite sure, Roger, where you saw the spike. On the left of the screen. Am I in a position to share it?
You can do, I think, yeah. Yep, your screen's showing again now, Tim, or your presentation showing again.
Oh, here. Is this? I would need to have some input from Roger. Is this what he's referring to?
Four slides earlier, he says.
4 slides earlier. That one?
Roger says no.
Is it a light curve or an image? It's just a bit of a guessing game. Sorry, Roger.
It's a light curve. The next one, maybe?
Roger should now be able to speak if he unmutes himself so he can ask the question directly.
That would be helpful.
Hi, Tim, can you hear me?
Yes, I can hear you, Roger.
Yeah, it was a light curve like the one you've shown here,
Yeah.
but the center step was quite short and the spike was on the bottom left of the curve. Keep that one.
Okay. Good question.
I just wondered if it could be.
Yep, this is a real event. What this is, it's a double star being at the limb of the moon under Gray's conditions, and the minor component, the fainter component, appeared, okay, and then disappeared. Then there was a short period of time when the minor component appeared again, followed by the main component of the double star. So
I guess with my sort of exoplanet hat on, I said, this might be a planet, or it could be gravitational lensing, or maybe neither. You know,
nothing quite as exotic as that. But this is simply a double star with one component brighter than the other, being revealed at the edge of the grazing instance of the moon. This is a very powerful way of actually detecting double stars. It was a known double anyway.
Okay, thanks then, Tim.
Okay, you're welcome. It was just a nice example showing you what you can see at a grazing occultation.
Eric Walker also commented that he's got a C11 in a permanent observatory and a C8 as a mobile telescope, so he's going to have a go. So hopefully Eric will be able to get in touch with you, Tim, and share some results.
I use my C11 for the focal reducer. I have it reduced down to about f5.6. Otherwise, the field of view starts to get a bit constricted. So yeah, plenty of opportunities out there now. More observers. That's good.
And I guess it helps to have them all around the country as well.
It does. There are certain areas of the country which have a lot of observers. Well, I have to say, I admit I may have caused a growth of observers around the Reading area in southern England, but and Alex has encouraged people in Northern England, and we've got two observers in Ireland as well now, one observer in Scotland, but we do definitely need more people around, really, observing these things. So the more the merrier.
When you were talking about the observations of these binary types of asteroids, which are presumably rotating as well, that means when you come round to another occultation, it won't necessarily be in the same sort of orientation as it was the previous time.
Yeah.
So how much how much can you take that into account, or do the professionals take that into account when coming up with the shape for the asteroid?
Generally speaking, we do have good information on some objects and very little information on others. But those which we know are of greater interest and have been observed a lot, then we can make provision for in the predictions to take into account rotation and changes of orientation in some cases, yeah. Well, even like Pallas, for example, it looks almost circular, but even so, it's not exactly. And there have only been 4 asteroids visited by spacecraft, and we know what they look like very, very precisely now. But even Pallas, we don't know a great deal about, other than the fact that it's almost circular, slightly oval, and that's an object which we like. It's possible to get more orientation on it. You know, as you say, it's rotated a bit the next time round, but we don't know. So we just observe it and collate all the observations.
Good stuff. Well, we don't think we've got any more questions coming through on the chat.
Is it possible to stop my screen share and show my desktop, do you think?
Yeah, let's try that and have a look at your videos. Oh, you've got your desktop there now, yes, behind.
I have.
Yeah.
Excellent. Okay, well, I'm going to show you something. If you've got a couple of minutes.
Yep, it's all ready to go.
I'm starting a cult. There we go. Cult 4. This is the latest edition of it. 4.10.7.0. And in it, there's a shape models demonstration. I wanted to show you this earlier. Okay. So this is, these are all the shape models generated by light curve and asteroidal occultations. But in some cases, like Ceres here, it's actually, the model is derived from imaging, satellite imagery. But we can play the plot. So it's actually moving at 1 degree steps, and it's almost circular. Now, if we take Pallas, for instance, obviously the interesting thing about this is the axes are all over the place. This is the north-south axis, and this is a model based on occultations and light curves, and you can see it's not circular. Vesta has been visited by a spacecraft, and that's extremely well known. That's not circular either. And in theory, if you had an occultation, a grazing occultation, you could reveal some of these finer features if you were extremely lucky in being in the right place. Right at the bottom here is a Rockoff, and that may be a strange name, but this is the one that was visited by the New Horizons probe after visiting Pluto. And this is the satellite, well, the probe obviously was able to image it, and that was the task under sort of, that was the aim of the project. As you can see, this is a bilobate structure, and it was deduced by occultation measurements across South America by observers, and it matches the satellite observations. That was a nice one. So that's really what I wanted to show you there. Do you want me to show the videos? If we've got time?
Yeah, we've got a couple of minutes yet, so don't see why not.
Okay. So this is the double star video, lunar occultation, and it's celestial mechanics in action here. So you can see the dark limb just creeping up on the first component of the double star, and it'll wink out. It's gone. It's already gone. And 11 seconds later, the other one. These are 9th and 10th magnitude stars, and the bright side is overexposed, but there's a little 11th magnitude star there. I wouldn't be able to time that, that's too faint. This is a grazing occultation, which I did earlier on. It's perfect conditions for. So this is the dark limb illuminated by the Earth, of course, and there are about 8 different contacts at the limb of the moon. And I've often been asked whether I've seen any meteoroid impacts on the moon during these events, and the answer is no. However, if you look at this next, I'm just creeping this image along to number 35 minutes here. So can you see my cursor? There's a flash there.
Yeah.
Was that the last one? Well clear of the illuminated side. I'll just replay it. Where the cursor is, there should be a flash. Just there, yeah. Well, that was a satellite glint. Not an impact. Bad luck. So this is my last shot. It's an asteroid occultation. Electra. It's an ideal event to pick up. It's a bright star, and it's a very clear disappearance. Yes, there's gone there. Yeah, the star's gone. You just see the asteroid. And the asteroid is still visible. The star's gone. I can see the asteroid. So this is the ideal situation for an observer. A very clear disappearance and a long duration. So there we are. Is that okay then, Callum?
That was brilliant. Thanks. Thanks very much, Tim. Yeah, it's quite surprising how long that asteroid occultation was. I always sort of envisaged that they're all sort of fractions of seconds type things, but I guess it depends on the size of the asteroid, doesn't it? So,
yes.
Yeah, of course, yeah, fairly obviously.
Yep.
So just one question. Do you have to have a wide field of view? Was a question from Dave.
A what field of view?
A wide field of view. With an f8 scope, say.
If it's wide, it should be wide enough to include at least one comparison star. That's the only criteria. But if you see an event and there's only one star in the field of view, you don't know if it's anomalous caused by seeing conditions. So you have to have a separate star which you can compare it with. So yeah, there's no restriction on the field of view, except that you need to have a reference star, ideally.
And the question from Stephen is does the software do the photometry automatically and produce the light curve?
If yes, you have to load the software, load the light curve into the software and select the stars. But then it'll go away and do it and present the light curve.
So you load the video into the software.
Yes.
And then it
You do, yes.
does all the processing for it, right?
I could demonstrate that if you wanted.
Yeah, I think time is maybe getting on a little bit. So
Okay, no worries. But yes, it's relatively easy to use.
okay, great. Well, thanks very much, Tim. That was a really fascinating insight into occultation observing, and I hope might inspire numbers of observers to get out and have a go at doing them, whether lunar ones or asteroid ones, and see what results they get. And I'm sure Tim and the asteroid and remote planet section will be really appreciative of any observations that you managed to get. So thanks very much, everyone, for attending this evening, and to Tim for presenting, Dominic for looking after our IT tonight, and to everyone for attending. Just a quick reminder, our next webinar is on the 14th of October at 7 p.m. again. American, we've got the American astrophotographer Adam Block will be joining us from Arizona, and he'll be talking about the interpretation of astronomical images, about how he goes about visualizing things, or the astro images that he takes. So that should be quite interesting, I think. So thanks very much, everyone, for attending tonight, and look forward to seeing you next time round. Bye for now.